Good day, grade 11s, and once again we are back together, right? And we are continuing with the proving of trig identities. So please, if you haven't subscribed, just make sure that you're part of the family. And we are continuing with number 7 this time around. So if you haven't watched the previous videos on me introducing this section, we've already done number 1. We've done number 2 in one video. We've done 3 and 4 in one video. We've done 5 and 6 in one video. And if you still want to, master this section, go and watch those videos before you actually get into this one. So today I'm only going to do question 7. And obviously, because it is a little bit involving, so I don't want the video to be longer than it should be, as well as question 8. But I am going to do question 8 separately. So let's get right into it. Right, so we are given there, right? So remember I said we work with the left-hand side and the right-hand side separately. So we've got sine squared of theta divided by, we've got cos squared of theta plus 2 cos of theta, okay, plus 1. And this, we want to prove that this is the same or similar to what we've got on the right-hand side. Sorry for that device blinking a bit there. Right, so that's going to be 1 plus cos of theta. Now, here's where we are going to start. So if I look at the left-hand side, in this case, there's quite a bit to do, all right? But on the right-hand side, I've got everything in terms of sine and cos. There isn't really much that we can do in that regard, right? But when I look at the left-hand side, we're going to have to be a little bit more creative in answering this one, okay? They're unlike the previous ones that we've done thus far, but nonetheless, it's still the same body of work. Okay, I'm trying to draw a straight line there. Okay, there we go. All right, so let's work with our right-hand side. I already see that on, the left-hand side rather, I already see that on the right-hand side, I've got something that, well, relatively speaking, I can't change, but it has a cos of theta. Now, question is, how can I change the square of sine into cos? Well, you know this by now. That gives us 1 minus cos squared of theta. Okay? Now, if I look at what I have at the bottom, right? That looks like something I can factorize. It looks like a quadratic expression. Think about it. If we said let cos theta be k, that would be k squared plus 2k plus 1, right? Now, if I were to factorize that, how would I factorize it? It would be k plus 1 into k plus 1. So it does look like we can factorize that. And when we factorize it, it would be cos theta plus 1. And that would be cos theta plus 1. Nothing wrong if you said cos theta plus 1 all squared, right? Now, we already have to some extent something that looks like what we have on the right-hand side. We just need to get rid of one of them. But if you look at what we have at the top there, that is what we call a difference of two squares. I've already shown you in our first video, right, how that can be the difference of two squares. So that will give me 1 minus the cos of theta into 1 plus the cos of theta. Remember, anytime you are factorizing the difference of squares, it will be, right, the square root of the one and the square root of the other in different brackets with different signs in between them, right? So at the denominator, what do I have? I've got cos of theta plus 1. I've got cos of theta plus 1. Now, please keep in mind, ladies and gents, these are exactly the same because we know that addition is commutative, meaning that the order doesn't matter. If I wrote 3 plus 2, it's exactly the same as 2 plus 3. So the order doesn't matter. And so we say that it is commutative, right? So in this case, what do we notice? Cos theta plus 1 is exactly the same as 1 plus cos theta, right? And what does that give us? It gives us, what we have left now is 1 minus the cosine of theta divided by 1 plus the cos of theta. Of course, what I did at the denominator is swap these around. But remember, because of what I said, that addition is commutative, it will not change the answer. So ladies and gents, what do you notice? Left-hand side is equal to right-hand side. Okay. Perhaps just to show you, you could have actually decided to do this differently by focusing on the right-hand side, okay? So I'm going to try and do that here, all right? And that's why I said that I wanted to do this one on its own, right? So if I'm just going to focus on the right-hand side, you've got 1 minus cos of theta divided by, okay, let me not use brackets, divided by 1 plus the cos of theta. So what you could have done, remember here, and on the left-hand side, we've got sine squared of theta divided by, this was cos squared of theta plus 2 cos theta plus 1. Okay, now how do we prove that this is actually equal using another method? Right, if I notice at the numerator, I could have applied a little bit of some mathematical gymnastics, said, look, what if I multiply the numerator with 1 plus cos of theta so that I can make that into the difference of two squares. But remember, for this not to change the fraction, I would need to divide by the same, right? So in essence, I'm just multiplying by 1 because the numerator and the denominator are exactly the same, so I'm not changing the equation, okay? Right, so what I do at the top, I need to do at the bottom. Now, if I apply our distributive law there, what do we have? We've got 1 times 1, which would be 1, 1 times cos of theta, which would give me cos of theta, and cos of theta, negative cos theta times 1, that would be minus cos theta, and negative cos theta times cos theta would be minus cos squared of theta. And of course, and that's supposed to have a theta there, right? And divided by, at the denominator, again, if we use our distributive law, right? Okay, so we've got 1 times 1, which is 1. Okay, we've got 1 times cos of theta, which would be cos of theta. We've got cos of theta times 1, which would be cos of theta. And finally, cos theta times cos theta, which would be cos squared of theta. Now notice at the numerator, okay, this guy and that guy cancel each other out. I'm left with 1 minus cos squared of theta. And this is divided by, now at the denominator, I've got cos theta times cos theta, which would be 1 plus cos squared of theta. 1 plus 2 cos theta, and this is plus cos squared of theta. And it's exactly what we've got on the left and the right hand side, except in this case, what we need to do is change that 1 minus cos theta into sine squared of theta. And we've got, in this case, we can use our the fact that addition is commutative. So cos squared of theta plus 2 cos theta plus 1. In this case, left-hand side is again equal to right-hand side. So I'm giving you those two options, right, as a way in which you could do that. Okay, and notice we just applied a little bit of creativity here because we wanted to change that into sine squared of theta. And ladies and gents, and that is how the cookie crumbles for question 7. Right, in our next video, we're going to be looking at question 8. But please, before you even watch it, try it on your own and tell me what your answer is. It would be nice to give me that answer on your comments section, right? And oh yeah, maybe we can't exactly do that with these guys, but please let me know if you got that. Otherwise, I'll see you guys again next time when we do question 8. From me, it's sharp sharp.